And I'm going to depart a bit from my usual stream, like the title suggests, which, did I set it up right? Yep. I'm a C++ guy, but I'm going to be making a React web app tonight. So, what could go wrong, right? So, in the last couple streams, I have been developing a pretty simple demo app called the chat room. What am I demoing? It's my new implementation of WebSockets, which I did 3 or 4 streams ago. WebSockets being an extension to the web server that I've been writing from scratch in C++. So anyway, we have a bunch of WebSocket tests and a bunch of chat room tests, which I can show you we can run in our test framework. But how interesting is that? Not really. Kind of dull to watch tests run, really. Chat room. Hold on. Web server chat room. Debug chat room tests. So we have 8 different tests. Our chat room, we can't really do much in it, but we can load the chat room, connect to it, set our nickname. We can send a tell. We can join and we can leave. And the tests tell us that it should be working, but kind of boring without a real UI. So that's where React comes in. If you haven't seen React, there are plenty of streamers out there who will demonstrate it, but it's a framework made by Facebook, and it's based on JavaScript and all the latest ECMA script advancements. And there's a whole site, reactjs.org, where you can learn all about it. And someone who shall not be named right before this stream went through the tutorial to get a little refresher. So I haven't actually done much outside of C++ in a while. I did React back in April a little bit, enough to get my feet wet, but I feel like I've forgotten most of what I learned back then. So tonight will be the night to kind of have a little chuckle at my expense as I try to struggle with it and get something that will talk to our web server's chat room. So that's the plan. We're going to start a chat room web app. We're going to establish a React app. I'm going to use this tool called Create React App, which is a command line tool, which will set up a skeletal React app, fully functional for us. And I think just to start off with something easy, I'm going to just put buttons and an entry box in there so that we can test connecting and disconnecting to our server. And if I feel bold enough and I get enough of the basic components I need working in React, we'll try to add a chat log. I guess what we want for the chat log, really, we want to be able to type in a tell and send it to the chat room, right? The chat log will let us see the messages we type, and we can play around testing with several different browser instances to kind of pretend that we're different people. Oh, we need to be able to pick a nickname, right? Or maybe we'll make that part of server connect and disconnect. Actually, no, I'm going to keep them separate because I had the concept of lurking, which is connect to the chat room server, but not picking a nickname, and then you won't show up. Oh, but we want to be able to show... let's be able to pick a nickname and then show nicknames. Show non-lurker nicknames. It's a little bit different from Twitch. For this demo, a lurker is just someone who hasn't set their nickname, not someone who's not chatting. We won't allow tells unless you have a nickname set. But if you set a nickname, you're no longer a lurker even if you don't say anything. Anyway, I don't know how far I'll get into this plan. Adding the chat log, it might be pretty challenging for me because still getting started, like this page says. I was taking a look at this component I've used previously, React Virtualized, and it has, where does it say it? In the documentation, there is a component called Grid, which I don't know if they have a demo here or not, but it looked pretty cool, a way to show our chat log and maybe even have different columns like a column for the nickname, another column for like the time that the tell was sent, and then a bit larger column for the actual text. But we could also use list as well if we don't want columns. And it's just something to allow the chat log to get pretty long and not burden the app trying to draw the entire log. And there are other features in here like I think it's a window scroller, so you can embed the list or the grid inside of a little scrolling window. But I'm really weak on CSS and React in general, JavaScript in general, so I don't know how far I'll get, but let's give it a shot. And yeah, okay. So first step, hold on, before I even get started, let me make sure that my web server actually will run and that we can actually talk to our chat room. So we have a configuration file here for the server, and I think I have, so I have it set up so if we go to /chat, we'll talk to the chat room plugin. And so let's do that. So we'll say web server, debug web server, tell it where the configuration file is. And now with my nifty little Chrome instance, and you can see I was playing around with the tutorial from React App. I should be able to go to localhost 8080. Well, first of all, there's not index, but static index. You can see it ends up, can you guys see that? Okay, yeah. You can see that it ends up going to our custom web server, fetching content back. And actually, the browser cached the entity, so it didn't even need to download it. Just got it not modified. I can force a refresh with shift reload, right? Yeah, so now it got it 200 okay. We can open up the developer tools to see this. So network reload. And is there any indicator? Yeah, we didn't put anything in the response headers, something like this came from Excalibur, but trust me, it did. So I think right now if we go to chat, it just says coming soon. And that's because let's see, the chat room plugin, which is web server, chat room plugin, source, chat room plugin. I think it's programmed right now where if you don't upgrade the connection, it just says it's coming soon. We should probably change that. Now that I think about it, where is it? Not receive message, it's one of these guys. Oh, hold on. It says coming soon because I forgot to update the plugin. So let me do that. It's web server chat room plugin debug that DLL. So copy that DLL to web server debug plugins. And yes, override it, please. And you can see back over in here in the web server, it unloads and then reloads that plugin. So yeah, right now it's not doing anything to the connection. Interesting. Let me check to make sure I'm doing the right thing. Oh, because it's not coming in as a WebSocket connection. Yeah, so this chat room plugin expects the connection to get to be upgraded. Let's actually put something in there. Yeah, where we make sure. Yeah, okay. That's the problem. We don't have. So okay, I lied a little bit, I guess, when I said we'd be jumping right into React, because I want to polish up our chat room plugin to do the right thing. If you don't open it up as a WebSocket, but it'll just open up normal. So this shouldn't take too long. I want to make a new test called connection not upgraded. So what we'll do is we'll expect that the chat room plugin does not try to assume it's a WebSocket, but it gives us a reasonable error message like, please try again as a WebSocket. So, let me expand this. I want to look at, we have some code in our setup. Yeah, right here. Hold on. Yeah, this server register resource delegate is what we're going to call. Because we're going to make a custom HTTP request to our chat room that's not a WebSocket upgrade. So this will be this will just be request. And request method is get. This target is chat. And actually, now that I think of it, I believe that this path is not correct. And yeah, so this is just a response. Hey there, Rally Monkey. If you just joined in, I was gonna jump into React, but then I realized that my chat room doesn't really do the right thing if you connect and you're not a WebSocket. Oh, look at that! Thanks for the bit. 1 bit. Woohoo! I have now collected exactly 1 bit ever. All right. What we want to do here, I guess we need a connection, don't we? Okay, let's make one. And where are my connections? Where are my connections? Mock connection, here we go. So, const auto connection. Standard make shared. Hold on, I'm gonna move my mic a little bit. I don't know if this is gonna cause noise or not. Oh, hi Gremlin, how's it going? What am I supposed to say for Yokusei? That's a reference to Deathlord. Very old game. That's one of the words that opens up one of the gates, right? Kobito hide gold. Am I right? Probably no one understands that reference but us, but that's fine. Kobito hide gold. So yeah, in about half an hour you'll get to see me embarrass myself trying to write something in React. But right now I'm finishing up something in C++. So yeah. How did this work again? Oh, right. We have to set up a send data delegate. And here, I guess what we'll do is we'll just have it collect the response. So response text, and then put it here, response text. And it's basically response text plus equals standard string data beginning to end. So Gremlin, I'm pretty sure no one has a Wolfram stream. So if you did one, it would be the very first one, and I'm sure you get like 100 views right away because no one else does a Wolfram stream. Just saying. All right. This is the connection object we're gracefully giving it. So what we're gonna do is expect that if we just do a normal request, we need to parse that response, don't we? Standard. Oh, actually, we can just say HTTP response. Smash coding stream. Yes. Pretty sure no one's doing that, but you know what? Let's search at some point and see if anyone does that at all. It might be a pretty narrow niche. Okay, this is response. Oh, we already get a response. Duh. I don't need to parse it. So I really just need to assert that we get a 200 from the response status code. And let's expect something like content type text plain. There you go. If anyone is interested to know what Smash is, that the link Gremlin just put in there links to what he codes in. So shout out to Gremlin and his Smash coding system. Well, I mean, it's not, he didn't write the Smash, he's using it to make his own games. Okay, assert, and let's expect a cheerful body, like try again, but next time use a WebSocket, please. K thanks bye. How do you say K thanks bye? K thanks bye. For the response body. So, anyone else is viewing these, Gremlin and Rally Monkey are know each other from IRL. So, if you see something you don't understand, it's probably a inside joke. Okay, thanks, bye. Like that. Please. Please. That was just K thanks bye. Anyway. So this test will fail, of course. Let's watch it fail. Close the server so we can run our tests. That's had that in the history here. Oh, what happened? We don't have a default constructor. Why? Oh, because that's right. It wants us to give it a string. And we'll just call it mock client. A string that identifies which side of the connection it is. Because in the test framework for these tests, we have both sides being mocked, the client and the server. So there we go, we're failing. Okay, so it's actually really bad. The status code isn't even valid. So let's go fix that, shall we? I think what we want to do is handle this failure here. Right now, we're just dropping the user that we just set up. What we'll do is we'll say the status code is 2. So it's going to tell it okay, but you know, try again with a WebSocket. Let's see. Headers, right? Set header content type text plain. Response body equals just this. And let's see if that fixes it. Oh, this is wrong. It should, I had these flipped, and also we're not just comparing the string, we are doing a response headers.get header value of the content type header. There we go. So now if we run, hold on, run the web server. Well, first, let me out my other window. Update the chat room plugin. Now run the web server. Where's that? Here. Now if I reload this, just try again, but next time use a WebSocket. Okay, thanks, bye. All right. So now it's time to first check in, and then I'm gonna drum roll, please. I'm gonna start jumping into React, which I'm totally unfamiliar with, but we'll give it a shot. So Excalibur I just changed the web server, right? Yeah. So let's check in that change. We'll say chat room plugin return reasonable response when not opened properly. Just a canned reasonable response. Because it was not being reasonable at all before. Oh, that's right. I had some fixes on the Linux side of things. So let's fetch rebase and then push. And then there are probably other repositories I fixed too. So let's do a mugget pull, which is what you guys can do if you have gotten my code from a previous stream and you want to get the latest. Just go in there, do mugget pull, and you get the latest. Yeah, I found and fixed some things when I tried this stuff out on Linux. So we want those fixes. I better quit the web server before it tries to link a new version of it. Okay. Sanity check. Okay, it still says that, and then this still says the static content. Okay, so let's do the React app. So here's how you start a React app. Go to the parent directory and you do create. Well, I installed. I'll tell you what I did in a little note. How to get set up for React development, and it's all kind of summarized in the getting started in React. So I'll link that. So first, it's install node.js, and there you have a link here. Oh, hold on. It was the practical tutorial, not the getting started. So the install node.js was this link. Then, like they say, you do npm install -g for global create React app, and that pretty much does everything you need to get your basic setup for React. You only have to do that once. Then, when you're ready to anytime you want to make a new app, use that create React app. Or is it npm create React app? It's just create React app, right, and then the name of the app. So we'll call it Chatter. Because why not, right? And call it whatever the heck we want. So what it does is it downloads all of the prerequisites of React DOM, React scripts locally. So we're going to get a local copy of all of the framework from Facebook, like all of the different components that go into React DOM, React scripts. That's why you see it here fetching. And I'll go through a brief overview of what you get while it's booting up. So let me think about this. I guess let's make another shell. Okay, and go to Excalibur. Chatter. You hear Git. Oh, I missed that chat that you hear Git. Do you hear kids in the background too? There's some chatter in the background. It should be undistinguishable because my mic is so awesome, but sometimes their yelling gets through. This is actually taking longer than I thought. Okay, actually, while it's going, I'll show you. Since I did the tutorial earlier, and the structure is pretty much the same, I'll show you that tutorial looked like. Open recent React Sandbox. So you get this huge directory called node modules that has a local copy of all of the framework. Along with that, there's this package.json, and that kind of summarizes at the top level what the dependencies of your app are, the name of your app, the version number, and all of the NPM scripts. NPM stands for Node Package Manager. Oh, you heard rebase and fetch? Yeah, I was doing that earlier to pull in a change from my Linux machine. But that sort of deserves its own little YouTube video, like intro to basic Git. But tonight we're just going to talk about React, I think. So these dependencies here pull in other dependencies, which pull in other dependencies. And you can see the complete list if you go to package lock.json. This is the complete list, and there's quite a few components that you get. Each one is a JavaScript library with its own version number, with its own listed dependencies. And the cool thing about it is the Node.js package manager, the NPM, manages all these dependencies for you. And the developers of each package, as long as they keep their version numbers up to date along with the versions of their dependencies, then it all kind of recursively pulls in everything you need. And you only really need to manage your very top level dependencies here. So this is using version 16.4.2 of React, which is probably just because I pulled it from the latest tonight. And we don't have to worry about all the other things that are underneath the hood. So yeah, it also gives us a nice little README, which has a whole bunch of like help text in Markdown that you can read through, which I probably will read through to set up lots of different things. So I talked about node modules. That's where all the dependencies are. Public is all the static content for the app. So there's the fab icon, which is the symbol that shows up here, right? There's the index.html, which is like boilerplate. Basically, it says you need to enable JavaScript. And if you do have JavaScript, it pulls it in through, where is it? I think it's this manifest. No, that's not that. It's one of these. Where is it? Oh, I guess it's injected. Where does it say that? It should say that here in one of these comments. Okay, I guess it doesn't. But if you end up, when you load the app, you'll get an extra link which is pulling in all the actual JavaScript. And yeah, this is sort of like if you're familiar with Android apps, there's a manifest file which has metadata about your app. So I don't know too much about this other than what I can kind of guess, that these are your default colors. This is the top level page for your app, etc., etc. The app itself is always under source, and I think it's this manifest, one of these. Maybe it's just by default. It goes to index.js. And so React kind of looks like this. It's a mix of JavaScript and HTML. They call it JSX. And alongside your JavaScript, you'll have the cascading style sheet, which is used to pick fonts, pick sizes, pick colors, that kind of thing. How's the stream delay? Testing 1, 2, 3. Stream delay is kind of big, isn't it? Wow. I'm seeing like 10 seconds or longer. Anyway, it seems like it's taking a long time for the chat to come through. How did you get 3 bits in there? Oh, I see you cheered 1 bit with the dog and 1 bit with the Mr. Destructoid. I didn't see that. Those little ones are hard for me to see. 5 more for my first bite, yeah. Okay. So let's see if React's, yeah, so create React app is done. It tells us it pulled in these libraries, which if you pull in all of its dependencies, you get a staggering 1,320 JavaScript packages. And it tells you what commands you can do that are kind of built in to the skeletal app that it makes. And npm start is what you really kind of want to do while you're developing. Let's do that now. Oh, we got to go into the directory. I forgot to do that. So chatter npm start. So, okay, it opened it in the wrong browser window. So let me just copy that over to here. Oh, I already had it. So yeah, refresh. So there's our web app. This npm start actually launches a node.js server locally, which is just hosting our app. And it basically says how to get to it. And this is the app. So that's what it looks like when it's rendered. And let me try to put that side by side with the code. Let's move back to Excalibur. And let's shorten that a bit. So chatter, here it is. So index.js, this is the top level render for the whole page. And basically it says it's going to render one app. I think it's called a component. They have two words, right? There's component. Hold on. Component and what? Component. Sorry, I'm feel obsessed about finding this name. Okay, they're both components. One's called functional, and the other one's interactive. Actually, I don't think that those are the right words. So I'm just not even gonna explain what it is until I see it again. Anyway, the app will refer to this. It'll basically pull it from the app.js, and here's app. It's going to have a header part which has our logo, which is that spinny thing. And then the app title, welcome to React, shows up there. So if I go in here and actually say exclamation mark and hit save, look at that. It shows up right away because the Node.js server is detecting changes to the source, and if it sees it, it'll rebuild it. So yeah, I don't remember either. Yeah, so it's pretty cool. You can, as you're editing your JavaScript or your HTML, it reloads. In fact, it says it to get started, just edit it, save to reload. So here's a paragraph, the app intro, right there. And yeah, that's all. They just give you one component. You usually don't touch this index.js very much. You're going to be making changes to the app or making subcomponents. Oh, and by the way, the first time I did that tutorial, I was wondering how they do that spinny atomic symbol, right? What I found out is this: if you go to this logo, it's a scalar vector graphics. That draws the path of that atomic symbol. And to get it to rotate, it's in the CSS. They have animation, app logo spin, inflate 20-second linear. The key is this animation. This is the tag for it. And then what the browser does is it looks for keyframes. And this is basically giving it instructions on how to generate the animation. So it's going to transform from 0 to 360 degrees over a span of 20 seconds. I mean, you can almost figure it out, even not even knowing or looking it up in the CSS manual, right? So if I said 10 seconds, now it's spinning twice as fast. If I said 1 second, it looks really comical, right? If I said 180 degrees over 5 seconds, interesting. I guess it still looks like it's doing a full circle, but if I do 9, let's just do 1 second. See, here we're only doing 90 degrees and then starting over, right? 10 degrees, 360. So it's actually, I kind of find it kind of fun to play around with the CSS and see instant reaction in the browser. So the CSS is just giving instructions to the web browser on how to render it. So the actual mechanics behind animation and keyframes are all built into the browser, which I think is pretty cool. So anyway, so what I think we need to do is add a couple buttons. Maybe we'll get rid of the distracting logo for now. And that being so tall, I don't like that, so that it's in this height, right? So how about 20 pixels? Oh, that's lab logo, which we don't have anymore. Header, it's this height, right? Maybe 60. And then I'll make it say chatty. And let's, where is it? Text align left, maybe. Can we have a white spinning rabbit instead? I'll leave it up to you guys to just run through the Create React app and follow along. How about that? I kind of don't like how it has no margin on the left, so let's add a little margin. Margin left 1M. Okay, I don't want to. I didn't want to do it to that part, so maybe it's just the title. No, not the title. It's the intro. That's interesting. Oh yeah. That's what I want. Okay. Okay. That's enough CSS for the moment. So let's get rid of app intro. Let's introduce another component. So we'll call it, I don't know. I'm thinking the box where you're gonna the combination of the box. We need a box to fill in the address of our server and then buttons like connect and disconnect, right? So since I had no idea what the name is, let me look at the docs. Components, and actually it's probably an API reference, right? What kind of components we have? Actually, where do they say what kind of components you have? Is it main concepts? See, this is the part where you can start laughing at me for knowing next to nothing about React. Web components? No. That's something different. I know it's not uncontrolled components. Okay, it's probably not in the advanced guides either. Maybe they describe it through this main concepts, different topics here. No button. You're giving me one bit at a time. It's like you're feeding me breadcrumbs. It's interesting. Like, you would think a frequently asked question would be like, how do you make a button? Well, I'm gonna do what every good engineer should do, is Google search it. React button. Oh, okay. I see. Yeah, they don't have components for things like buttons because you're just supposed to use an HTML button. So let's make a button. And we're going to say connect. There's our connect button. Okay. I really need to put some more. Okay, this isn't the app intro anymore, is it? Oh, that's right. We lost the class name. That's what I want to have, right? So It's not app intro though, really it's controls? Or main, I guess? Main panel? Just to make sure that that matches our CSS. Okay, so we have a connect button. Let's have a disconnect. And hold on, let's make a app main. How does this work? Is it then button? Shoot, how does this work? I'm gonna have to look up basic CSS. This is so embarrassing. Embarrassing. I want to say buttons that follow CSS cheat sheet. Need a cheat sheet for CSS, please. Okay, yeah, that is right. How come it doesn't like that? Actually, why didn't it put a margin? It should have put a margin between the buttons too. Let's inspect and find out why. Computed. Oh, yeah, it doesn't apply to descendants, that's why. Okay. Margin right, 1M. There we go. That looks nicer. Hi, Nook. Have I used Firebase before? Nope. Sorry, don't know what that is. So yeah, if you just joined in, I'm embarrassing myself thoroughly by jumping into React as a C++ hardcore developer who knows next to nothing about React. But I need something to talk to my chat room in my web server that I wrote from scratch, which is sitting here faithfully waiting for us to connect to it. So I know next to nothing about JavaScript. You're watching me embarrass myself live and try to figure this out. Google's cloud database. No, but I was looking into Amazon Web Services today. So I don't know very much about Azure, Google, or the other ones. I know a little bit about Amazon Web Services because I was reading about it today, but I'm still a noob when it comes to that stuff. Okay, we have buttons. Let's put this in a div. And then have, let's see, I guess, what is it called? Entry? Or what's a, what's an entry box in HTML? How about HTML cheat sheet? I love cheat sheets. Where's my cheat sheet? Oh, no, these are not readable. Can't they just give me a cheat sheet that I can read? I would like to read it, please. Okay, fine, never mind. Whoa. Whoa. All right. HTML entry box. What is it called? I just forget what it's called. Input. That's what it is. Input. class name equals. Actually, it doesn't really matter. We don't need to give it a class. So there we go. Text input. Text input's better than input? Oh, are you talking about is there a React component for text input? You're probably right. Oh, okay. Text input's in React Native. Yeah, we're doing React.js, so yeah, I'm gonna stick to basic HTML for now. So input. Yeah, but we're quickly gonna want to make a component out of that. So shoot. How am I going to do this? I need to get the data back in. I guess I'll just look at how they use it here. Control component. Okay, yeah, it has a prop, and it's got two props, value and on change. Yeah, and I don't need to, I can just do that. You have to give it some state, so server URL on change equals this dot change server URL. Why? Oh, that's why. Okay, so this is indented weird. Let me fix this. It's like Control Shift F or something. Nope. I was looking this up earlier and now I've already forgotten it. VS Code reformat, auto reformat. See? I did look it up earlier. Shift Alt F. How am I supposed to memorize this stuff? I don't know. Okay, it would help if the cursor is in the correct place. Shift Alt. There we go. Okay. Constructor props. Super prop. Is it super props? Super props. And this dot state equals server URL null. There we go. And then change server URL. Oh, there's an event. Yeah, that's right. That's what a control component is. It handles events, right? Okay, there's a trick for just modifying part of the state, right? So object. I can't remember. Again, watching me embarrass myself. State and life cycle. Never type slash anymore? Well, I'm a hardcore C++ guy, so it's in my blood to type semicolon as much as I can get away with. Well, that's to be seen, right? We haven't looked at your code yet. Do you want me not to look at your code? Then I'll never hate you. I don't know. I've looked at a lot of people's code over the years, and you have to grow a thick skin, and you have to be able to be tolerant of other people's code, I think. All right, so state and life cycle. Okay, I'm looking for the magic stuff that I haven't quite memorized on how to do how to construct the new state from the old by just changing one thing. Oh, here we go. How to use it correctly. Yeah, but how do I change just part of it? I feel like I'm getting close here. Merging. Ah, I see. This. Oh, hi there, Ix. How's it going? Are you? I hope you're prepared to laugh a lot because I'm jumping into something completely unfamiliar to me, which is JavaScript and React. I'm jumping into the deep end, you might say. What is this props? Okay, that can be whatever I want, right? So prev state. Oh, the props at the time the update is applied. Okay, that's not what I want exactly. Where was it here? There's an event target value. Oh, well, can I just pass that in? Let's see if this works. So previous, okay, it's a function object we're passing. Props. Why did I choose React over other frameworks? I evaluated Angular, and really, actually, I should, to be fair, I haven't really given Vue a chance. But I was looking at Angular and React, and I liked how unrestricted or flexible React is compared to Angular. Angular felt like a walled garden where you had to use everything from one place. In React, you can kind of pick and choose things that work with React. You know, whatever you can pick what you want and not have to pick everything. Another reason I picked React is I found some other streamers on Twitch who use React, and they're really helpful and nice, and so it gave me a good feeling about it. I still feel very foolish trying to show you guys coding in it though, because I'm definitely way outside my comfort zone here. Okay, what I want to do is set the server URL to event dot whatever this guy said, target dot value. Will that actually work? So if I say A, B, C, oh no, set state, cannot read property set state. Eh, it said I could though. Oh, I wonder if it's because we have to pass this. We have to bind that, right? Something like that. Yeah, okay, so that's okay. I'm expecting to see that server URL change, but and I'm not seeing it. So I'm doing something wrong. Whoa. Let's collapse that guy for now. Okay, so that should... Why does it not like it when I press... Cannot read property set state of undefined. Why is it undefined? I'm literally copying from this thing here. This dot state equals that, yeah. Oh, yeah, they did the bind thing, right. I don't like that syntax though. There's a better version of that I read somewhere. Let me just search for that. So, what is it? New JavaScript syntax bound method arrow functions? Maybe that was it. No, that's not it. That's it. That's it. So it's like change server URL equals event arrow that. Now I can... Nope, still didn't like it. Oh, value. All right. No. Hold on. Let me refresh that. Cannot read property value of null. It's event. Oh, do I have to pass in event here? I shouldn't have to, should I? Let me just try, instead of this arrow thing that's confusing me, let me just try this. Oh, there we go. Ha ha ha, got it to work. I have no idea what I just did. So, localhost, I want to be able to type that, or what is it? Is that the port number I put it on? 8080, yes. And I want to hit connect, and it should open a WebSocket. That's what we want to see. So, let's put another div here, and we'll say WebSocket status, and then we'll print something here. This dot state dot socket status, and we'll put that in a span. Class name equals socket status. And CSS. So I guess I should stick to the convention here. Well, what if I do this? I need to brush up on my CSS stuff. I'll just do this for now. We want to say like colors or font weight, I think, bold. And then we need to actually set it. So it'll be start as disconnected. Should we shout? Why not? Disconnected, right? And then app main div. Let's give it some space. margin bottom, I don't know, 10 pixels. Okay. Anyone really good at React is probably cringing big time looking at me code this up, but I figure as I'll learn, I'll come back and fix my mistakes. So, how do we I think we handle buttons is there's like an on click, right? Button on click equals this dot connect on connect. And on disconnect. So let's just pretend that it actually does something. On connect. Well, there's no event. This dot set state. So socket status. Connected. Maybe we'll shout if it's connected and not if it's disconnected. And then on disconnect. Is it the same thing? I think it is, but I need to bind them, so it's equals that arrow. There's an explanation I read, I forgot why, but doing this kind of thing, or what they were showing back, where was it? Where was it where we first saw this? This stuff right here. There's an explanation behind that, and I don't remember other than, oh, why is that? I don't need that open. Suffice it to say, this does the same as that bind thing, and it connects the function or the method to the this so that you can actually access it. It's a foreign concept to me because in C++, you always get a this if for a method of a class. So I'm sure when I do my homework and read more about it, I'll be able to explain it, but I can't right now. Anyway, that should fix it. Now when I connected, disconnected. What's cool is I'm using this plugin. How do I show that? Okay, don't know how to show it, but in Chrome you can install a plugin that integrates with React, and so it's kind of showing you the state of the app, live, which is kind of cool. Very useful. All right. I suppose what we'll do is we need to have a, not in the state, because the state is really for immutable objects, but we need to have a WebSocket, right? Socket equals, I guess we'll just initialize it to null. And here's where I gotta look it up. So it's JavaScript WebSocket. Here it is. I was looking at this earlier. So you use a constructor where you pass the URL to it. So we would say, comment that out. We'll say this dot socket equals WebSocket. And then this dot server URL. Actually, let's format it. Actually, we don't have to web format. We'll just do ws : plus this state server URL. That should work, right? Does that connect right away? Oh yeah, so we add what we do is we add listeners. How do I, if I do that, will people see it better? Maybe. There we go, that's better. So, this.socket.add event listener, open. And then I'm going to use the arrow syntax. This dot onConnected. Actually, you can just do, how does this work? I guess you just do that, right? Then on this onConnected. Then I wanted to move that here. Okay. Now, let's initialize this so I don't have to keep typing it every time. Localhost 8080 chat connect. Okay, fine. New. Connect. Did it do anything? Pending. Did it actually do something? It did. I don't think it did the right thing, though. It was supposed to have tried to upgrade the socket. But it broke the connection. Why did it break the connection? Oh, it says pending, though. Oh, I'm looking at the wrong thing, aren't I? It's chat I'm supposed to look at. Oh, it didn't upgrade the connection. It should have. It should, because it says upgrade WebSocket. It's failing for some reason, though. I guess we can run that in our debugger and see why. So quit the web server and let's bring up the debugger. So set up our web server to run. I don't remember if I configured this right though. Oh, I did. Okay. So I can just run and we'll set a breakpoint in our plugin here. Go. And there's its window. And then I'm going to go back to my app here and hit connect. So there we go. Let's look at the request. It's maybe hard for you guys to see it, but there's a get. It's got a bunch of headers. Host connection. Connection's probably upgrade, right? Connection's upgrade. Upgrade is WebSocket, and here's the correct key. So something happened here. It's failing for some reason. So let's find out why. So connect again. Let's go inside there now. Method is get. It had a version. Interesting. It didn't think it didn't think it found the token upgrade. It's there though. Did this get header tokens not converted to lowercase? Yeah, okay. I think I forgot to do that actually. So that's a bug in our, what is that? In our WebSocket implementation. So it should have done a case insensitive compare, but it didn't. Go to connect. See, it's comparing capital upgrade with lowercase upgrade. This get header tokens, it's supposed to convert everything to lowercase, but I think I forgot to do that. Yeah, so in addition to stripping the white space, margin white space, we're also supposed to convert it to lowercase. So I forgot to do that. All right, so let's fix that. That's in the WebSocket library. So following test-driven development, I need to first make a test to capture this bug. And then I'll show that the test fails, and then we'll fix the test by fixing the bug. Okay. I'm just trying to see if what's the closest test to this. Wrong upgrade, maybe? How about we'll take a complete open as server and copy that test, and we'll call this one complete open as server upgrade capitalized. So, or connection token capitalized. So it's just, that's the only change there. We don't need to check all of these things because we know the test will fail to even open. WebSockets test debug WebSockets tests. So yeah, it's failing. So let's fix it. The proper fix, I think, is... Oh, wait a minute. It's actually technically not in WebSockets, is it? It's in message headers. So we fix it there in message headers test, it'll fix it in WebSockets as well. So let's make a test case there. Oh, I already had one for get header tokens. All right, well, let's just modify the existing test. In fact, we'll make it a little bit aggressive. We'll capitalize some things and not other things. So that'll cause that to fail now, when it shouldn't. Test debug message headers tests. There we go. So, get header tokens. Call split tokens. Just a local function. I thought I had something in here to normalize the case. Nope. Normalize? Maybe not. Hold on, let me just make sure. I only call split tokens from here, right? Okay. Is it normalize case? I think I have a function called normalize case in WebSocket. Not that one. The implementation of WebSocket. Yeah. I've been meaning to pull this out into a common string utilities library, just haven't done it yet. So just temporarily I'll make a copy here. Normalize case insensitive string of that. That should fix that bug. Need to get that overlay where I show a little graphic of a bug being squished. WebSocket test is still failing though. Interesting. So why is that failing now? Let's see. That should not have failed. Oh, I'm running the wrong test. WebSockets test. Start up project. Eh? Oh, yeah. Okay, so it doesn't do it for the last one, so we need to fix that. That would have been in message headers test as well. Where there is, yeah, so it's a case where there is no, so like, for example, this capital foo. See that? So we have to normalize the case in both places. Actually, shouldn't that strip the white space off too? So like if we had that, a space there, it should strip the white space off. It does strip the white space off. Oh, because we strip it off there. Okay, yeah. So we just need to normalize the case of that remainder. There we go. And there we go. Let's check those in. Oops. That little red block means that it has some white space in there where it shouldn't be. There. Okay. Fix bug in case sensitivity of header tokens. Normalize case of all tokens parsed by that function. Get header tokens. I'm such a klutz these days when it comes to the keyboard. I need to be paying more attention when I type. Or retrain my brain. Somehow I've gotten sloppy on the keyboard. No. Git is asking me to clean up the garbage. Run garbage collection. I'll do that some other time. Yeah, so this is just a test to make sure connection tokens are case insensitive. Case insensitive. Alright, so that should have fixed the web server. So I'm going to go, okay, that window's for our web app. Here, I'll use this window for overwriting, or maybe I should just build it into this one. No, I'll use it here. So overwriting the plugin, right? So the web plugin is in web server chat room plugin debug DLL, and then we have to copy it to web server debug plugins. Overwrite, and then web server debug web server configurations one level up config.json. Okay, now rerun our WebSocket test. There. Connect. Ooh, crash the server. Cool. Okay, how did the server crash? Let's find out. Let's just run it in the debugger. Why does it think message headers needs to be built? Wonder if that was a sign. Reconnect. Retry. Huh. Okay. Let's load the symbols on these standard libraries. I'm not sure what the exception is. Ooh. System error at a memory location. Oh, it was closing the connection while it was trying to open it? Oh, the connection was closed. Actually, I don't get what the error is. Deadlock would occur. Ooh, bad news. So we're trying to lock the processing lock. Was it because it's being destroyed? Nope. Maybe another thread though. What's going on in these other threads? Nothing? Ah, yeah, something is going on there. Two threads are simultaneously trying to close the same WebSocket. I think that's what it is. Oh, wait a minute. No, it's the thread is trying to join itself. Well, that shouldn't happen. I think I see what the problem is, though. Yeah. So, for some reason, the connection was broken from the React app. And so it called the broken delegate, which called connection broken on the WebSocket. So then it indicated it back up. Where does it do that? Oh, that it shouldn't do that. It's trying. Oh no, it's closing the local end. Which yeah, it shouldn't do that, should it? I'm not sure how to fix that the cleanest way though. Right, it'll break out the processing loop. Yeah. Yeah, so if if the transport connection is broken, we don't want to call close on it because it's already closed. It should just do nothing though. But yeah, so two problems. This 1006 is reserved for if the connection is actually already broken. If that's the case, we don't want to do this. What? What happened? Did I change something? Why does it say stale? Okay, I messed something up. Let's try that again. Yeah, I typed something by accident. That's what happened. Recreate the bug. Oh, huh. Yeah, that'll happen if I don't recopy the web server each time. Okay. Yeah, so if code is 1006, we don't want to call break. I mean, we could, it should do nothing. That's the second problem is if we tell the connection to break and the connection, if we're in the processor thread of the network connection, it's going to try to stop itself. This true should only be if the calling thread is not the processor thread. How difficult would it be to write a unit test for that? Maybe not too bad. So that would be in system abstraction tests, network connection tests. Yes, they don't even have a real test for what happens when you break the connection, and then try to call close in the close callback. Let's duplicate this test. Close during close. So server cloner, okay. I'm not bothering to check those return values because the other test tests that. What's this client connection owner thing? Owner. Yeah, so we need one of those. But we're going to rig it here. Close when connection broken. We'll not do it normally. If this flag is set, the connection is closed during the broken, what is it, Borken. Connection broken callback. Borken, I like that word actually. Connection broken callback. So we'll say do this first, and then without holding the lock, we'll say if it's that, then Oh, we don't have. Oh, let's just make it a delegate. If this is not okay, this is a function to call when the connection is closed. As simple as that. So it'll be standard function void connection broken delegate. We just simply call it now. If it's not null. You don't want to call a null pointer. That would be bad. So in this test that I just made, it's closed during broken connection callback. So it's client connection owner dot that equals okay, actually I'm going to set it up down here. Client dot close. So connect, process, and then we close it on the server side. So what? Server connection owner dot connections 0 dot close, right? And then we wait for it to be closed. It's like this dot await closed, await disconnection. Actually, we need to do this first. Okay. That's system abstractions test debug system abstractions test. Okay, yeah, so it crashed, right? So we should see that crash. So this test is now reproducing the crash. Although we're not seeing it actually happen. Oh, no, it's not. It's not the same crash. And to see it, I need to turn on C++ exceptions. Eh? That's a weird. Is it because it was caught? Debug assertion failed. Maybe it's here that's happening. Let's see. Is it because these connections? Yeah, okay, never mind. Oh, it's clients, right? Clients. Is that not right? Owner has no clients. It's supposed to put it back, push it back into connections. a minute. Hold on. Maybe I'm not understanding this right. Okay. That's never actually used. That's not used either. So I didn't understand this right. It's just clients. Yeah. No? Oh, are we not waiting long enough? That's probably what it is. Yeah. Okay, we're not waiting long enough. Gotta wait for it to connect and then close it. There we go. And there's the memory error, so. There we go. So I've recreated the bug. This shouldn't happen right here. So the fix to the bug is it's standard this thread get ID is not equal to impl processor. What is it called? What's the thread? What's the variable name for the thread? It's whatever we join later. Shoot. Well, this doesn't have a concept of processor, does it? Yeah, so we can't put it here. So default that to true, the way it was. And we go into this one. So it's another condition here. So it's if standard this thread get ID equals platform processor get ID. Or not equal to, right? So it shouldn't join itself. Now, that should have fixed that crash at least. Okay, so fix one thing. No garbage collection yet. Fix crash when it's a network connection. Fix crash on close during broken callback. Okay, so let's run the web server again. It's still going to do a close, which should be ineffective. I'm curious why Chrome is disconnecting the WebSocket so quickly. Oh, there it didn't disconnect it. It's connected now. And how do I see that? I guess it's one of these that's marked 101. Yeah. Code -1. What does that mean? I think I need to clear these. That's the problem. So refresh. Connect. There it is right there. Oh, oh, what happened? Request timeout? Connection's empty? What? Oh, shoot. Yeah, we don't want to time out connections that are no longer... Oh, yeah, okay. I forgot about this. When we upgrade a connection, the web server should no longer, like, really care about it. It should just remove it from its list. I'll fix that in a minute. One problem at a time. I want to know why this thing is saying opcode -1 for that WebSocket. This one. This WebSocket is the one built into the React debugger, I think. This one is ours. Why is it saying opcode -1? $79 bytes? I wonder if it's seeing that timeout. Yeah, let me, That's probably what it's seeing. So yeah, that's maybe the same problem in this thing. It is, well, hold on. Let me raise the timeout values to very high levels so that it doesn't time out, and then we'll see if it still happens. So the timeouts set to 1 second. Let's make it 1,000 seconds and 6,000 seconds. All right, reload that guy. Okay, and while it's connect, no, it's still getting something back. If I'm understanding that correctly. What are these console messages? Incorrect accept header value. Really? It was incorrect. I guess we're not generating the accept header correctly. There's the accept header. So I guess it didn't match our key? I guess that's it. I guess so, huh? It's supposed to take that and then append salt and then hash it. Oh, that does look kind of long. Maybe we have a bug in calculating the accept for a key, for a given key. So that's interesting. So I need to remember to look at the console here. Well, I have I have more bugs in my JSON. Not my JSON. My web app. Div cannot appear as a descendant of a paragraph, really? Where were we doing that? So right here? I guess what we want then is we want a div, not a p. Logo is defined but never used. I guess we don't need, we didn't need that logo anymore. Okay. So yeah, so our server is not generating the correct accept answer to the to the initial key. So let's figure that out. And then so we have two problems. We have that, and then we have the fact that the web server is still monitoring the connection even though it got upgraded to a WebSocket. So I'm curious what happened to our WebSocket tests that tested the key, because I thought we had tested that. It would be complete as client due to wrong accept, right? Oh. Yeah, we never really did pre-compute these to make sure it's correct. We should probably do that based off of the actual WebSocket RFC, right? Because they had an example in there with a real key and accept. So here's a key and here's the matching accept. So we should probably just build a test for that. So actually, let's just build it into this thing. Or should we? No, I know what we'll do. So in this succeed one, a complete openness client. Where is this done? Oh, this won't work, will it? Maybe the openness server will. Yeah, so here instead of using this junk, we can use it from the real standard. So there is the key. Actually, it's already encoded, isn't it? That's the actual key. This is what we should actually get back for the accept. Right? So it probably have a bug in that code. And we never caught it because the bug is probably in the test as well. So that is WebSockets test debug WebSockets test. Yep, that's it. So what does it look like? It looks completely wrong. This is what we should have gotten. This is what it actually gave us. So that's totally wrong. Let's step through that then. See what's, well, actually, I guess we can look at the code and see what it's doing. It's taking the key. It's base 64 decoding it to make sure it's the correct length. Okay, it's this compute key answer that's probably wrong, right? Base 64 encode a SHA-1 of the key plus the salt. So let's put a breakpoint there. Run WebSockets tests. Then put a breakpoint here. So there's the key, correct? D capital G, is that what it starts out as? D capital G, right. So it's supposed to append this salt string to the end of it, and then call SHA-1, and then base 64 encode the result. So let's see what it's actually doing. So there it appended that string onto the end. And then so it got back out that SHA-1. Oh, you know what's the problem? Is SHA-1 is a string, not a sequence of bytes. Yeah, okay. That's the problem. And that's what we're doing wrong in our test too. So this is returning it as a hexadecimal string, but we actually need the raw bytes. So what? Modify SHA-1 or modify this compute key answer? I'm inclined to modify SHA-1 to have an overload that gives it back as raw bytes. So that would let's do that. So in SHA-1 tests, we'll add another test, SHA-1 tests, and it will be hash, well, hash2 byte array, byte vector. And we can borrow from one of these, right? We can borrow this stuff, borrow that vector. So it will be expect equal standard vector of uint8 t, these bytes, but we got to convert them now. So like this. Okay, I didn't quite get that wrapped correctly. 1, 2, 3, 4, 5, 6, 7. I guess we'll cut it at 8. Does that line up? Not quite. 10 is 20 bytes? Is that right? 2, 4, 6, 8, 10, 12, 14, 16. Yeah, 20. So we really just need an overload that doesn't return a string. So let's call it SHA-1 bytes. And let's make the other one string. So let's actually search let's search the whole project for that. So that's SHA-1 string. So then we can make that bytes. Actually, all of these bytes. And that's why our test didn't catch it before. Because our tests had the same bug that the code that it was testing had. Okay. So it just means we need to have 2 more overloads. The original ones are string. And these ones are bytes, and they will return a vector of integers. One of these guys. And let's make it clear here. Is returned as a string of hexadecimal digits, as opposed to the other one, which returns a digest as a vector of bytes. Okay. SHA1.cpp. This is string now. So what I'm going to do, I'm going to move the algorithm itself down to the bytes variance. This one. Like this, down to here. And we still need this other variant that takes a string in. So 3 of the functions just call the 4th one. So bytes to bytes, right? So right, so what we'll do is we'll get yeah, so this is going to change a little bit. Well, this copy here. So, okay, const auto digest equals SHA1 bytes data. And then it'll be width 2. Actually, it's just for auto byte digest byte in digest. Oh, this is wrong. So string set with 2 and then output digest byte. Return digest string. Well, string builder. String. Okay. And the actual algorithm, instead of doing this junk, it will make a vector of bytes that's exactly 20 long. And it just has to fill them. So digest, well, actually, we can just do this. And we can then return it. Okay, we can reduce it down to just returning it, can't we? So it's H0 shifted right 24 and FF converted to uint 8T. $16, 8, and nothing. And then again for 1, 2, 3, and 4. 1, 1, 1, 1. 2, 2, 2, 2, 3, 3, 3, 3, and 4, 4. So that's 20 lines, hopefully. Yep, that's 20 lines. So from the bottom up, it'll be SHA1 test debug, SHA1 tests. Ooh. Okay, I completely broke it. What did I do? Oh, okay. It's when it forms that string I didn't do it right. So what did I do? No? It should have worked. Huh. I don't see the bug, so I will have to run it in the debugger. Not that I have to, but it's just quicker that way. So, okay, that didn't do what I thought it would do. Let's start over again. Digest byte is A9. Digest string builder is nothing. Now it has 0 A9 in it? What? Oh, how do I see the whole thing? Why did it do that? Oh, is it because it... Okay, I think I know why. The uint 8, it doesn't know to output as an integer, right? Let's try it now. Yeah, that was it. I thought that shifting out a uint 8 would shift it out as an integer, but it's shifting out as a character for some reason. I would expect it only to do that for a car. Okay, anyway, so that fixes SHA-1. Or not fixes, but we enhance SHA-1, really. Provide byte vector output variance of the hashing function. And then the other test that failed before should pass, right? Yep. Okay. So does that mean we're good? Let's see. Update the chat room plugin and then run the server. Server, where are you? There you are. And then reload the React app. Hit connect. Oh, look at that. So, chat, timing, not finished yet. Great. So it looks like connection works. If I hit disconnect, will it do the right thing? Oh, we didn't actually have disconnect do the right thing. What if I just hit reload? I was hoping to see a connection broken, but I think only the server prints that out. We don't actually have the WebSocket printing that out. And actually, because of that problem with the WebSocket not clearing the connection state, it's going to leak, or it's going to hold on to a memory structure for that connection, even though it's gone now. So let me think about this. Oh, well, let's put into the web app here. How did that? Oh, I know why. I'm answering my own questions before I vocalize them. I changed that paragraph to a div, but I didn't put in the margin stuff. Where was it? App main. Oh, right. A paragraph has a default top margin, but not the div. There we go. I just wanted some nice space there. Okay, let me implement the close because I'm missing that. Or disconnect, really. So it's what? How do we disconnect a WebSocket? We call close. Okay. So I'm not, I'll put in error checking later, but on disconnect we just call this.socket.close. So connect, it's pending. We disconnect, it's done. Connect. Okay, so that's working. Need to fix the problem about the web server holding on to its state for the connection, and also I want to add some diagnostic messages for when the WebSocket state changes. I think I want to see that. We might as well just print debug messages for everything that happens with the WebSocket. Okay. Time to check in some code. So, yeah, that was a bad bug. It was taking the hexadecimal string and base encoding that rather than the raw bytes. So, fix its WebSocket. Fix bug in how sec web. What's it called? WebSocket-accept is computed. Base 64 encode the SHA-1 hash bytes, not the hexadecimal string. Rendering of the hash. Okay, now what changed at the root? Oh, I suppose we should check in chatter. Public manifest, yes. It's going to complain about that for all of these files, isn't it? What if I cheat and do just a git add dot? Then it complains all on my console, not here. And I'm not going to check in the config change. We don't need the logo, actually. What do we do with these tests? Leave them around even though I'm not using them right now? Okay, so establish chatty web app. The web app currently doesn't do much other than let the user open, close a web socket to a server whose address is given in an input box. Yep. I'm gonna drop the logo and we're gonna drop the timeout changes. So remove the logo because we don't need it. How is my stream doing? I'm doing okay. I guess my stuff is kind of boring though. I only got 2 viewers. But thank you, whoever you guys are, who are sticking to it with me. Okay, yes, we're going to fix the problem about the server holding onto a connection. I think what I'm going to do, I have some timeout tests in the server. And right now the bug is we're seeing it try to time out a connection even after it's upgraded. So that'll be a good check actually. We'll upgrade the connection in HTTP test and we'll assert that they never time out. So let me take a timeout. This inactivity timeout will do. So we'll say upgraded connections should should not be timed out. Or at least not timed out by the server. We do want to handle timeouts for WebSockets in the well, do we want to do it in the WebSocket or the chat room? I suppose we want to make it part of the chat room. So make a timekeeper. Set the inactivity. Actually, I'm going to do... Instead of using the inactivity timeout, we'll do the request timeout. It's just in this request, we'll make it look like it got upgraded. It doesn't really matter the protocol we actually upgrade either. Actually, is that a valid test? No, it's not. Yes, I need to change this a bit. So that terminates that request. Oh, but okay, yeah, that's right. We need to... Hold on, how does this work again? It's got to tell the server that it got upgraded, so... Oh, that means I have to... Okay. Really, I need some of this stuff here. Yeah, so we need this part. But I need the timekeeper stuff. How's the timekeeper get given? Oh, depths timekeeper. Got it. So we upgrade the connection. Well, that's technically not correct, but we are upgrading it there, so... So yeah, after upgrading it, so... This, we don't need any of it. And we actually don't need any of this stuff at all. Don't need this. Don't need any of this stuff. After the request, we advance the time past where it should have timed out. Oh, we didn't set the... I didn't set the timeouts. This thing. Request timeout. Mobilize depths. It's right before that. Right here. So there's a request timeout of 1 second. So when we advance the time here, Yeah, we'll assert false. That should be enough. Because what's happening now is the web server is going to actually respond with a timeout message unexpectedly. HTTP test debug HTTP test. So it actually crashes. So it's worse than it failing, it crashes. Let's see that. Yeah, so that's what we were seeing in the live web server too. To solve this, I think all we really need to do is remove the connection from the connection state if it gets upgraded. I suppose we can treat it like a broken connection, because those are just removed and the Reaper just clears them. So yeah, let's handle it like a broken connection. So we'll call it, instead of broken, these are the client connections that have broken. Well, these are the client connections that are no longer managed by the server because they have either broken or have been upgraded and are now handled by a resource and will be not destroyed but reaped. Really, they're dropped. So active connections, what's a good name for this instead of broken connections? Old connections? Inactive? Old? Connections to drop? Let's call it connections to drop. So a lot of references to that. We need to put connections to drop there. In the first place is we can't drop a connection that's in the process of calling us through another. Yep, exactly. So old connections to drop. So it'll be the same thing. This is on connection broken call while holding the mutex. Yeah, okay, so we're good. We just need to do the same thing. This is, we insert it into connections to drop, notify the Reaper, and then remove it from the active connection. So we'll do that on the 101 that we see here. There we go. So that should solve the crash and also the unexpected timeouts that are being sent back. So HTTP server. Server should stop managing upgraded connections. Upgraded connections. Treat upgraded connections like broken connections. Drop them from the Reaper thread. And until they are dropped, don't interact with them or interact them, i.e. don't trigger any timeouts or yeah, that's basically it. Okay, I actually didn't expect to find so many bugs in the C++ code. I thought this stream would be all React stuff. So it's been a bit of a mix. Of things. So let's update the chat room and then run the server. Go back to React and reload. Connect. We can connect again. Disconnect. Yeah, we don't get a disconnect diagnostic message. I kind of want to see that, so let's do that. That would be in what would it be? WebSocket tests? Do we have any diagnostic message handling here? No. Actually, does WebSocket even have diagnostic message support? I don't even remember if I put it in there. No, I didn't. Well, we should add that. So it would be like the server. So server tests. Have a test for that, right? Diagnostic messages. Okay, I guess it's built into the tests themselves. Except for that one. Alright, so let's go to WebSocket tests and include sort of the same things that we need. They have diagnostic messages in a subscription. Maybe we should go away from the subscription token thing. Well, no, we'll leave it in there for now. Very soon I want to refactor that subscription token out, actually. Okay, so it's in our framework. Oh, we don't have a framework. Let's make a framework. WebSocket tests framework. Or fixture, really, not framework. Fixture, just for diagnostic message collection. So, oh, I guess we need a unit under test, so that's this WebSocket thingy. So we're going to need to be able to subscribe to diagnostics and then unsubscribe from them. And then looks like I'm going to need to change all of these tests. Test open parentheses becomes test underscore f open parentheses. And actually, we'll have to remove those lines from every single test, because they're now in the fixture. I really should have seen that earlier, that all of these tests have a WebSocket, so that should just be part of the common fixture. Let's just search for that everywhere. Oops. It's a little bit faster. I need to clear that breakpoint I just saw. There's quite a lot of tests in WebSockets. I don't remember making so many. Clickety clack. Okay. Phew! Remove our old breakpoints. Yes, brother. Alright, so it needs subscribe and unsubscribe. So WebSockets already has the dependency system abstractions. It just probably needs the include. Send, yep, there. And then just like in HTTP server, which is where? Close that, close that, close that. iServer actually. Yeah, so these. Subscribe, unsubscribe. And those are declared pretty quick, pretty high up there. There we go. By the WebSocket. Okay. So subscribe. It's just one-liners really. So this implementation should go pretty quick. Hold on. No, I'm still in the impl. No, here we go. Here's where they go. WebSocket instead of server. And that diagnostic sender is a helper, which we put into the implementation structure right at the top, I guess. And we should include the same header. There we go. Why did it not like that? Oh, shoot. Yeah, so if you have one of those helpers, you have to actually give your name. Yeah, so, Yeah, so we'll have to do the same thing. Provide a constructor to WebSocket. Impl. And we'll say WebSockets WebSocket. To abstract? Oh, hold on. Yeah. Subscribe. I think it's because it's marked as virtual equals 0. Shouldn't be. I just copied it from iServer, that's why. Okay. So now we should actually build that into some of our tests, so Really, the only one I care about at the moment is close. How about this? And we'll copy from the server test that had sort of a pattern here to assert what we get in our diagnostic messages. Assert WebSockets WebSocket. And I don't know what level. How about level 1 for a close? So WebSocket closed. Yeah, okay. Where did I put that? Oh, there it is. Okay. Alright. I'll just put that test in there as the only one I really need for now. So it's not getting the message, so let's put the message in. So I think what I want to do is in the broken delegate, connection broken. Is that only called from one place? Yeah, so what do we want to print? What does the server print? I don't know. What does it print? Broken by peer. Okay. I guess we'll say the same thing that we do here. So diagnostic sender dot send diagnostic information formatted, right? 1 system instructions print it. Oh, we don't have that included yet. Sprintf, and it'll be connection to blank broken by peer. Connection to that broken by peer, and what we'll print is connection get peer ID as a C string. How come it doesn't like, oh, because this one does the printf for us, so we don't need string extensions. That's right. And the test, I should need to update that. That's connection to, what do we call it? Whatever mock connection calls itself. Mock client. Connection to mock client closed by peer. Alrighty. Still not printing it. Why not? Oh, because it's not broken by the peer. Yeah, it doesn't go there. It goes in the other place. It's not when we receive a close. It's the other. It's the connection unexpectedly broken one, right? We should, yeah, let's go ahead and put one for when it's orderly, when it's closed in an orderly fashion. Receive close. Connection to mock closed. It's actually supposed, it's broken, right? Broken by. So we'll make that one say closed by, and the other one say broken by. So that one should, That one says broken by. The other one will say closed by. So that's in the close delegate. Yeah, on close. So it's when we receive this opcode close, right? This thing. On close. There. I guess we'll put it after on close. Closed by peer. And then we should have one for when there's a fail. Doesn't really matter which one does it. How about we'll do it in unknown opcode. Connection to failed. Unknown opcode. We'll print the reason in the fail. So that'll be, is it on close? Oh, it's close. Okay, maybe not failed. We'll say closed. So this one we won't print anything for, because if I remember right, 1006 is where it's broken by the peer. So it's these where we will do something. I mean, not do something, we'll print something. Closed, and then we'll say here, reason, right? If there's no reason, it'll just be an empty string, which is fine. Oh, okay, we actually get two messages on 1193. That does actually make sense. I was thinking about that. Because it'll be closed by the peer, and then we respond with a close, right? So we should see those two here. Close received, so it should be here. Closed by the peer, and then at this point it'll say closed with no reason, because no reason's given. There we go. Okay. Okay. WebSocket. Add diagnostic messages. Publish diagnostic messages in these cases. Connection broken by peer. Connection closed by peer. Connection closed locally. Now, let's run the web server. Now when I connect to the chat, when I disconnect, oh, wait a minute. We're still not going to see, oh, it crashed. Interesting. It shouldn't have crashed. Wonder why. Let's see if we can recreate it. So set startup project, go. There it is. So connect, disconnect. Huh. Random crash and I can't recreate it. Hi there. Poor Diddums. How's it going? Well, I can't recreate the crash on my web server, so I'm not going to worry about it. Not now. It's not printing out the diagnostic message that I'm generating because I'm not actually in the chat plugin. We're not actually registering for diagnostics there. So let's do that. Chat room plugin. Oh, you know me from Botland. Great. Well, I'm doing a little bit of React today, but I am a React noob. So feel free to, I don't know, ridicule and laugh at me. I usually do C++, but today I am actually making a little React app just to test the chat room I've been working on, because my chat room uses WebSockets and I wanted to have something I can interact with WebSockets. So yeah, most of the time I'm doing C++, but today I'm doing a bit of React, and my React looks pretty gnarly. Pretty noobish. But it's functional. Just using it to test my WebSocket. Oh, and I was working on adding I wanted to add a little print message when my WebSockets get closed. Nice is that the interactive thing yeah, that's the interactive thing, so let me run the web server again. The interactive thing is I should be able to connect to the chat, and then when in a bit I'll be adding, like, you can type in a message and hit send, and then anyone else who's connected to the same chat room should see the messages, right? It's like what you'd expect with a chat room. So far tonight I've gotten just connect and disconnect working. Mostly I'm slowed down by the React stuff because the chat room itself, it's got this hold on, debug chat. Where did I put that? Debug chat room plugin tests. So we already have unit tests for setting our nickname, sending a tell, joining and leaving the chat room. We just don't have a React web app to show us all of that. We have connect and disconnect, but we don't have sending a tell or seeing people join and leave the room, or setting our nickname for that matter. But we're getting there. Yeah, so in the chat room here, when add user is called, where we have a closed delegate, but we need to print it here, I think. Oh, no, we're going to connect the WebSocket diagnostics, right? Yeah, did this have diagnostics to begin with? It does. It has a diagnostic message delegate. We should probably capture it here. And we pass it down, I guess? Yeah, let's pass it down. And then that means add user, got it. So where was that? Where did I declare the thing, the entry point? Oh, that was web server plugin entry point, yeah. Oh, I didn't even put the full name in there. Shame on me. Okay. Just copying documentation around here. Don't mind me. Okay, what we want, I suppose, is to set the diagnostic subscribe to diagnostics here. The delegate will capture this other delegate and forward it on, but with some annotation. So what's that delegate take? Okay, sender level message. So we have sender level message, and we will just forward it on. Although here we can kind of choose what we send. So we'll rewrite the sender name, and we'll say it's coming from. Let's do a little string formatting here. It's coming from user or session. Should I say session? Probably. Session number ZU, I guess. That's user. I guess we need to capture the user session ID. Okay, and the level and the message will preserve. There we go. Oh, can't write to it because it's still loaded in our server, right? Yeah, can't build a web server because it was still running. Okay, now it ran. Now it updated it. So install the chat room plugin, run the server. Now when I connect and then I disconnect. Oh, well, there's that crash that I've been having a hard time recreate. But look, there's our new diagnostic message. We close, so both ends of it closed cleanly. I wonder how often that crash happens. If I can recreate that, I'd like to. It's some kind of race. Actually, there it happened twice in a row. Connect, disconnect. Actually, it's actually very predictable. Connect, disconnect. Oh. Actually got it to happen. Retry. I thought it would ask me to pick a debugger, but it didn't. Let's see if I can capture it in the debugger. Connect, disconnect. There it is. So what happened? How come it's not showing me? Not showing me the exception for some reason. Access violation. Ew. So this is corrupted. Oh, okay. Oh, okay. I think I know what happened. We probably destroyed the WebSocket before clearing our delegates. So So this is a problem I fall into using these Lambda functions with captures, is that the thing we capture might have been destroyed but when our Lambda gets called if we forget to unset our delegates. So let's do that. We need to do that basically when the WebSocket is destroyed. So WebSocket's destructor. It's probably the best thing. So if impl connection is not null pointer, we'll set the delegates to nulls. Oh, that's the wrong kind of bracket. There we go. Let's see if that fixes it. Actually, I did the wrong thing there. I'm supposed to be doing test-driven development for the C++ stuff. I should have made a test case to capture that. Oh, no, it still broke. I didn't really fix it. Oh, that's why. I forgot. When I build the chat room plugin, I need to install it. Try again. Connect, disconnect. Still crashes, but it's in my destructor, so what's going on? Oh. Yeah, we shouldn't do that if it's been moved. Yeah. It's mostly my mental train of thought that's coming out my mouth, and Once I start down the dark path, is that how it goes? I'll make up for it and make a test case for this in a second. Is that how you could, or can you just do this? I guess you do that, right? Okay. Install plugin. Run web server. Wish I could make it so that it puts the output window in the same place every time. Connect, disconnect, still crashing. Okay, that shouldn't, I thought that I cleared those, I thought. Question, am I spawning the window or is that the IDE? It's the IDE, which is probably why I can't control where it puts it. Yeah, so yeah, I'm a little bit okay. Hold on. I'm not sure I'm understanding what the bug is here. So let me put some breakpoints in, see what happens first. What happens first? The crash or the destructor call? Let's put a breakpoint on the destructor call. Swoop. Open WebSocket, close WebSocket. Okay. Imple's empty though. Right, because it is closed, yes. Or it's closing. Users have closed, yes. Wait a minute. Yeah, okay, that's the problem. I think I figured it out. So it's the way we're moving WebSockets around. So this default is going to relocate the impl from one WebSocket to the other, but what we're capturing is the this. So our move semantics are a problem. What needed the move semantics anyway? WebSocket. Let's comment out the or delete them and see what breaks. So if we don't allow moving WebSockets around, what happens? Okay, we can't reassign a named WebSocket variable. And what's the other one? Okay, there are 2 places where we do that. 3 places. Where was the second one? Here. That's not the right place. Oh. The implicit move of a user. Okay, so we do need to support moving WebSockets. Just when we do it, we can't break our delegates. So I suppose we should just capture the impl, right? So auto impl equals impl got.get. That'll just be a raw pointer. And then get rid of the underscore. Then the delegates are tied to the impl, which gets moved. So that should work. You gotta be careful with the captures of lambda functions in C++. Compiler's not smart enough to always know if you might be using the things you captured after they've been destroyed. And oh, yeah, so whenever I see it not showing me the name of the function, it just tells me I forgot to install the chat room plugin in the runtime area. It's still, in other words, it's still using the old, the last build, not the current build. Okay, connect, disconnect. Okay, cool. No longer crashing. That's a good thing. So cool. I'm now getting the messages I was hoping to see before. Although I'm getting both a close and a broken. I guess that's to be expected. That means we sent a close, we got back a close, and then they broke their transport connection to us. Oh, I shouldn't print these at level 1, should I? Yeah, let's reduce that to level 0. So, well, first things first, I'm going to check in that the changes there. I'm going to see what repositories I was changing, because sometimes I'll forget. Okay, it was both WebSockets and web server. Right, so this was fixing in 2 parts the leaked delegates, which are causing it to call a destroyed object. So, oh, this is the one I needed the test for, isn't it? And I promised I would add the test, so let me do that. Let's add the test for that. So the right thing to do here is to stash it. Stash. And then recreate the bug in my unit test framework. I just have to pause and think, how am I going to recreate that crash? It would be if I wire up the WebSocket, then move it, and then call one of its delegates. Yeah. So is that right? I think that's right. So if I take any of these methods, what's something that's simple? I need a simple test. One of these that's not so complicated. They're all kind of long, aren't they? Can I do it as a unit test, or should it be an integration test? I'd like to do it in a unit test if I can, because it's easier to it's simpler to test it. Well, hold on. I'm not saying that right. If I can catch it as a unit test, then I can leverage all the integration tests off of the fact that I've caught it at the unit level, so I don't have to retest at the integration level. So it's like building that chain of trust. If the WebSocket tests itself that its behavior is correct, then anything that uses WebSockets doesn't really need to test the same thing again. Yeah. So so this would recreate the bug. It's send ping after moving. So we open it and then we just move it. So we say WebSockets WebSocket WS2 is WS is standard move WS, and then we try to ping WebSocket 2. That should cause it to crash, I believe. Unless I got it backwards. Yep. So We got a exception handler or exception thrown. Although I expected the ping to throw the exception. Let me think about this. What does ping do? Does it call a delegate? It calls send frame. Oh, okay, no, it's the other direction. It's on the receive. It's a receive. So where's the simple receive? These are all complicated. I want a simple one. That receive text wasn't too bad. I kind of want to keep that line around. Just put it in the right place. Receive text after moving. And so we're going to move it after we set the delegate, really. And then this should cause it to crash, actually. Yeah, in the test body. Good. So I could probably see that in the debugger. Step and yeah, crash. So it's this is null. So that's exactly the bug. And then we fix the bug with git stash pop, right? Oh, other window. Git stash pop. Ooh, it didn't fix it. I'm surprised. Oh, it crashed somewhere else? Let's see where. Unsubscribe from diagnostics. Oh, yeah, okay. We can't. It's the test framework screwed us over. It's always unsubscribing, but it's unsubscribing from something that's been moved. So we need to tell the test framework WS was moved. This flag is used to tell the, or I keep saying framework when it's a fixture, to tell the test fixture if we move the unit under test. If we moved. Because in the teardown, we only want to do that thing if it was not moved. And we will tell it that we moved it here. So, have the test not screw itself up. There we go. Now, I can say, this commit illustrates the bug and fixes the bug. So, yes, say fix bug in, or it's a fix crash caused by calling connection delegates after, okay, this is getting too long, so fix crash. I struggle with words sometimes. I want to make a good checking comment though. Fix crash related to moving WebSocket after moving WebSockets. Yeah, I try to keep good commits because too many times I've like looked back at changes I made 5 years ago and I'm like, I wish I had written what this check-in was about. It just says fix bugs. And I wish I hadn't been so lazy because I don't understand what I was doing in this code change, you know? Okay. Okay. And here's going to be a scathing note to myself. Be careful in the capture lists of lambda expressions. WebSocket was capturing this and using it in a delegate given to the transport connection object. If the WebSocket was then moved, the original shell of the WebSocket would be would still be used by the delegates. Fix this in two parts. Capture the impl, not this. Then the captures of the delegates don't change even if the WebSocket is moved. It's really just the impl changes hands from the old to the new WebSocket. 2, clear delegates in WebSocket destructor to prevent them from being called in the first place once the WebSocket is destroyed. And I wonder if I should say something about that. It's a conditional, because if you destroy a shell of a WebSocket, you won't go into that if. Remember to check in the destructor to make sure not to open the not to look into the impl if there is none. E.g., WebSocket was moved. Okay, stage those bad boys. Commit. Push that. Then I changed the web server too, I think. I think it was the plugin, right? Web server. Yeah, it was the plugin. Okay, this was a typo. I'm okay with a short commit there because I'll say, yeah, that's a typo. Wrong name, right? This. Oh. Yeah, we're printing stuff out now when. Yeah, we're connecting in WebSocket diagnostics back to the server. Guess I should try to make a test for that. Let's see. Does this thing? That's the plugin itself. Where's the test for the plugin? Right here. Hey, we're actually not doing anything with diagnostics. I don't know if I really care to test this thing. It's only for how do you like that message? That's if you try to go to the chat room through normal HTTP and not WS WebSocket. Like, try again, but next time use a WebSocket. Okay, thanks, bye. All right. I think I'm not going to bother with diagnostics at this level. Yeah, so let's just check that in. On second thought, I wonder, how would I test this? in the test framework, am I using, I'm using a mock server, but I'm using real WebSockets. Oh, okay, there, you can leave the room, right? By closing the WebSocket? So yeah, I can test it here. I know how to do that. Honestly, you would have tried that when you live? Sorry, I don't. Something lost in my understanding. Not sure what you meant. Yeah, I'm going to make sure that this what that diagnostic messages from the WebSockets make it all the way out to the chat room. So to do that, first we're going to assert that the chat room actually subscribes to diagnostics. Or actually, will it? No, that's not how the chat room works. We pass it a delegate, don't we? In a fixture. Yeah, and we're just doing printf. Okay, so yeah, okay, so we need to clean that up anyway. And do something like this, where we push it to the back of a list. And then keep that list around. Like this. Oh, is there more than one of them? No, there's only one. How come it didn't like that? Oh, because it's captured. This we can capture with this. When you went live with the chat room, I played around with the request. Oh yeah. Well, I don't have the it'd been really cool, but what I wanted to do for the stream actually was have this web server, this web server actually running on a public server somewhere, but it's not. It's just running my local subnet. If I could get this running, I was thinking of putting it up on Amazon Web Services. Then, like while I'm streaming, I could let my viewers interact with the chat room, or whatever else I'm working on, and try to break it or have fun. But I haven't figured out all the stuff with Amazon Web Services yet. Maybe in a week or so I'll have that running. Yeah, so this is running on Windows, and I'm making sure it's running on Linux, and I also want to support the Mac. I do that mostly through one of these libraries. I collapse all these. This library called System Abstractions is where I put things that are different between Windows, Linux, and Mac. So under the source, you'll see Linux, Mach, POSIX, Win32. So that's where I hide all the code that's different between OSs. So stuff like how you do network connections and certain things with the file system, they're all kind of hidden away in that library. Yeah, it was one of the things that I like to do is write code that's cross-platform, and I like to do it by collecting together all the differences and putting it into one place. So that stuff like my web server, it depends on system abstractions, but it has no like Windows or Linux or Mac specific code. It's just pure C++. So this diagnostics, we can then check for it just like we do in these server tests. Like that. So we had that close is a great thing. We can verify that we get a close message from the WebSocket. I just don't know what it's going to be. So we'll assert that there's no diagnostic messages, and for sure I will see one, right? Okay. Chat room plugin tests. Where are you? There we go. There we go. So session 23. That seems random to me. Connection to mock server 1 closed. Connection to mock server 1 closed by peer. How do we know it's session number 23 though? I think that depends on how many of the unit tests run. Oh, I know how we can solve this. That session number should just be reset after every test. That's here, I think. There was like a, right, room stop here. Yeah, we'll reset the next session ID back to 1. There we go. So it's always 2 because it's index 1. Session IDs start at 1, array indices start at 0. So we can say session number 2. The level of the diagnostic message is level 1. Connection to mock server 1 closed. And then closed by peer. Yeah, there we go. So that tests that we connected the WebSocket diagnostic messages back up. I did have a typo. So again, I kind of cheated. I should have wrote the test first and then wrote the code. Ooh, mutex destroyed while busy? I'd like to see that. Okay, it didn't happen that time. Oh, because I ran the wrong test. So it's getting about that time where my cat starts to yell at me because I'm supposed to not stay up this late. So if you hear a meow in the background, it's my cat yelling at me. Okay, there's the bug right there. The message, what was it again? Oh, out of range. Ooh, nice. Yeah, Kitty wants me to turn the lights off and stuff, I guess. Okay. Oh, is it recursing? It is, isn't it? It's calling receive frame. No, it's not. It's going out of range. Offset out of range. What? Wait a minute. Size is 33,000. Headers. Why is that out of range? This makes me think I have a race somewhere. Wow. I kind of wish he could speak English sometimes so I can see what he's yelling at me, or hear what he's yelling at me. Okay, send frame. Closing the WebSocket, and it's trying... Oh, because we're racing it, that's why. We're closing it when it's in the middle of receiving something. No, that's not right. This close causes it to send a close to the other one. Okay, why is it out of range, though? Temp. Hold on. What's it sending? Okay, I didn't expect to see this at all. It's the same test. It's destroyed while busy. And this time, so it is some kind of race. Because this time it was vector iterator plus offset out of range. Okay, let me look at what's going on with the threads. Okay, that's just, I don't know what these three threads are. This one's the chat room's worker thread, just sitting there sleeping. So it's not really a race, is it? It's there's something funny going on here. Oh, look at that. The data receipt delegate's empty. It's calling a null pointer. Sir, what's I? I is 0. Yeah, it's calling a null pointer. So why did it end up there? Oh, probably because this is completely bad now. Yeah, it's all garbage. Yeah, okay, so that's the problem. That one calls that close, inner close. This one sends a close frame. It sends the data, which then, right? I'm wondering why that's empty, though. Those ones are all set up. What's up with this one? Why are those empty? Oh, is it because it's been it thinks it's been destroyed? What? I don't get it. So I'm going to step through it and see. Reset, okay. This server connection. Huh. Oh, is it because of the change I made a little bit ago with the WebSocket? So that would be equals null pointer, right? This. Is that what's happening? Step. Yeah, that is what's happening. Oh, it did close it. And it is racing. Because it's being called from that worker thread. Okay. So yeah, we have to be careful then. These tests are not careful enough. These are racing us calling them from the delegates down here. So we need to use mutexes. Or just one mutex probably is fine. Okay, I already have a mutex. So we just need to grab the mutex. So I'm already yeah, okay. So I already had that idea here that there would be races. So there are races here too. That's what's happening. That is racing. Oh, wait a minute. It's called from there, so I can't use that same mutex. So let's call a helper. So server connection on a what's it called? Data receive delegate. Receive data, I guess we'll call it. Is this a problem with the setup versus the test? It's a problem with the test. That there's a race between the delegates being cleared by the WebSocket here and them being called from another thread, basically the test's main thread. Because I called them manually from that test we were looking at. Where was it? It was with the nickname, right? Set. It was basically when we call close. Call this. This is where it was actually happening, right? So this close. Where was that happening? Right, that close ends up having that WebSocket generate some data, which I think goes through this function call. But you see here, it wasn't. It's using something here that can be changed by this, which is being called from a separate thread. That's why I'm going to move that call into that test object and then lock the mutex from in both places. So we'll make a receive data. Void receive data const standard vector. I'm probably not explaining it very clearly either. I apologize for that. But yeah, so this call to the delegate and the setting of the delegate are happening from two different threads, essentially. So we'll make a mutex. Just call it mutex, right? I like to make as few mutexes as I can get away with. So this mutex will cover the whole object. This is used to synchronize access to this object's state. And we'll just lock it whenever we need to. You're a Java dev? Well, Java and C++ have similar issues, right? You can have multiple threads in Java, so you can have races in Java as well. Lock guard decal type mutex, lock the mutex, and then we'll lock all of these really. That I don't need to worry about. Oh, it was up here, right? There we go. So receive data. And I need to use it in the other place too. Only this is the client end. Hopefully that fixes the race I have. Ooh. Oh, yeah, that probably needs to be recursive, right? Because it could be the same mutex entered. The same thread could re-enter. So where was that? Not that one. This one. Recursive. Yeah, normal mutex in C++ cannot be re-entered in the same thread. So there we go. It is sort of racing, so there's a chance that I might not have caught all the races. I'm not seeing it happen, so I'm gonna be optimistic and say I caught the races. All right. Right, so there are really two problems I solved. Well, one problem and one new feature. So fix race in a let's check it in separately actually. This we'll check in the race fix first. Let's not unstage that then. Unstage that. And unstage that. Yes. So this one is purely about the diagnostic message. This one's purely about the race, and then there was no code changes. So fix race in test fixture. Do I need to describe the race? Actually, I do. So the test fixture main thread can manipulates the web sockets which cause data to flow through data receipt delegates. In another thread, the chat room can can also manipulate the web sockets. Was that right? It was is it the chat room? Yeah, it was here. Yeah, it was clearing the delegate. So in other words, the chat room can also was it clearing it? Yeah, so oh, because it's only one end of it. Yeah. In the test fixture's main thread manipulates the client side web sockets, which cause data through. In other words, the chat room manipulates the server side web sockets, which may change the data receipt delegates. Use a mutex to synchronize access to these delegates to prevent the race. Okay. And this was purely cosmetic. It was connect WebSocket diagnostic messages out to the web server. Cool. All right. I'm feeling better because I think we're back to a place where we have no errors that I know about. And maybe that means tomorrow I'll actually get back into the React stuff. So since it's getting late, I think what I'll do is I'll do a couple final checks and then kind of wrap up the stream and continue tomorrow. So let's see. Let's run some tests. Let's run all of our tests. And I was gonna say if any of them fail, I'll stay up until I get them to pass. But if I say that, Murphy's Law will kick in and then I'll be up all night. So anyway, they all passed. Let's run the web server and play with it a little bit. Okay, where's the command? Should make that a batch file, shouldn't I? Okay, connect to chat. Disconnect from chat. Connect again. Disconnect. Connect. Disconnect. It seems to work. Never attempt Murphy. That's correct. So yeah, I hope no one laughed at me too hard when I was working on the React stuff. Since I'm still a noob, this stuff is pretty gross and noobish, but it gets the job done in that we're able to connect and disconnect our WebSocket, and then it probably won't be that much work to actually add a box to send and receive. Oh, the sending is going to be easy. It's just going to be another box where you can type in some text and then say send. The receiving is going to be a little bit more complicated. I was thinking of using this guy. React Virtualized. They have a list component and a scroller, which I hope to use to make like a chat window. So yeah, we'll see how that goes tomorrow. Oh, look at that request timeout. Does this actually say if the connection's closed? It doesn't. It should say when it actually closed the socket, but it doesn't. Anyway, our web server knows that it closed it. And yeah, it's working perfectly. Look at that. After 60 seconds, it says that it's reached the timeout and just closes it. WebSocket should stay open for longer than 60 seconds. That's one of the bugs I fixed tonight. Once it upgrades the connection to a WebSocket to the chat room takes over that connection, and this should stay up until I close it. So let me wrap up the stream a little bit and talk about what I'm going to do tomorrow. So I started the chat room web app, and I kind of went over how to set up the app with Create React App, and I did a little bit of explanation about what are the pieces that you get from that command, like the different JavaScript libraries that are installed and and the manifest and all that. So we did a bunch of testing of connect and disconnect, and I did find a lot of bugs doing that. We didn't get to these things though. Being able to pick a nickname, show lurker nicknames, or non-lurker nicknames. Be able to type it, tell, and send it, and add the chat log. So that's going to get bumped to tomorrow. Because, yeah, while we were testing that, I found quite a bit of bugs I didn't expect to find. But it's good. You want to find your bugs early. Then I won't find them, hopefully, won't find more later. So yeah, right before the stream, I did run through the reactive, the tutorial from reactjs.org, and it's actually super easy to set stuff up. You just install Node.js and then npm install create React app, and you're good to go. But I did that so I didn't look quite so much of a fool setting it up on stream. Right now, our web app looks like that. So very sleek and stylish, basically nothing there. There's actually not much to it. Even in the JavaScript, it doesn't look too complicated. But we'll be adding, being able to set our nickname and then seat chat, and then what I'll be doing is opening up multiple copies of the app and then to simulate different users. And what I want to do eventually, maybe in the next week, is get this up on like Amazon Web Services and let my viewers connect to it and play around with it. Yeah, very minimalist. So yeah, let's see. I'll be streaming tomorrow. When? Noon tomorrow Pacific. So in about 12 hours, 11 and a half hours. So if you're interested in this kind of stuff, I'll hopefully see you soon. And let me think. Yeah, in about a week, if you check back in with me, I'll probably have this stuff up on Amazon Web Services while I'm streaming, so you can kind of play around live as I, push changes up to the so-called production server. I need to make sure I do it right though, so I need to do some research on Amazon Web Services and all that. So probably take me about a week. But yeah, this stream was a little bit unusual in that I had a mixture of C++ and the React JavaScript. Usually I'm doing all stuff in C++. But actually, as I'm moving on with this web stuff, our web server is actually pretty much stable, and we're actually adding the dynamic features, which is going to shift a lot of the work into the web app. So hope to see you next time tomorrow at 12 noon, high noon. And let's see, is there someone that we want to flip over to, raid, or host? Let us see. Well, there's a guy working on random projects in Rust who I have hosted earlier. So unless one of you guys has a suggestion for who to host, I'll flip over to Museon, if that's okay with you guys. We will see what he is working on. So yeah, we'll be hosting Museon if you want to stick around. Otherwise, see you soon. Thank you guys.